Hello and welcome. Today we're going to be getting into a little bit of video game development. We're going to be making our first 2D game, and there are many ways to make a game, different frameworks, different engines, languages, but today we're going to be focusing on Godot. Godot is extremely accessible for making games, and what I mean by that is it's super easy to use, it's super easy to learn, and if you're going to be going through the process of making a full game, this is going to give you all the tools you need. It even comes with its own scripting language, just like Python, but I'm not going to be using the scripting language. We're going to be using C# today. So a little bit about Godot though, it's free and open source and it's under the MIT license, I believe it is. So there's going to be no hidden costs or royalties. Anything you make with this engine is going to be completely yours. Like you will be the full owner. You're not going to owe anybody anything. There's going to be no teams of lawyers showing up to your doors if you make a lot of money off of your game. It has cross-platform development for Windows, Mac OS, Linux, Android, and even the web. It's super lightweight and efficient. It has a node-based architecture, which we'll get into, which makes the whole concept of developing in Godot super simple. Basically, everything's a node, and nodes compose other nodes. And of course, you can do 2D and 3D development, but today we're just going to be focusing on 2D. So the way that you want to get into this is you're going to want to go to the download section and you're going to want to download the .NET version of this because we're going to be using C# as our scripting language. Now the benefits of using C# of the scripting language are huge. Mainly, you get a huge ecosystem that comes with .NET to help your development, like working with JSON, working with an ECS system, working with SQL. .NET is a super mature, excellent language, strongly typed, and again, it has a wide variety of libraries and ecosystems that you can use in your game. So we're going to be doing the .NET C# version of this. And essentially, you just want to download the engine, just download this, it'll give you a zip file. You want to unpack the zip file into a folder. This is what we're looking at here. This is sort of just a folder that it unzipped with. Inside the folder that unzips will be a executable, a Godot executable. Now, if you're on Linux, for me, I can just launch this executable directly, just like this. It's gonna launch the window to another screen. So I'm just gonna have to move that over here. But I can just sort of open it up like this. And this is sort of the main project menu. And then here we can get started on the actual game development. Also, you're going to want to set up .NET on your system. I have mine set up for Linux already. And also you're going to want to set up your favorite editor to work with .NET as well. I'm going to be using NeoVim. If you need a NeoVim C# setup, we already have a video for that. You're welcome to check that out on the channel. And that's what I'm going to be using today. I'm just going to be using NeoVim, C#, Godot, you know, a typical CHAD stack development, CHAD game development. So I'm back in the Godot folder and I'm just going to launch Godot again. And then we're going to make a new project. So I can just go create right here. We're going to call this project Dodge Stuff. I know it's spelled Dodge. We're going to set the renderer to forward plus, but it's probably not 100% necessary. This is essentially going to set like the type of graphics you're aiming to develop for. Forward plus would be more advanced 3D graphics and stuff like that. We could select compatibility since we're just doing basic 2D stuff, but I'm just going to select forward plus for now. We're going to select Git as our version control, always Git. Make sure you choose where you want to save your project path and then click create when you're ready to go. All right, so the program should launch up here. I'm just going to send this over to another screen and make this bigger, and I'll just keep this window as my dedicated screen for now. We're going to do the initial project setup here, so I'm just going to the bottom left hand corner. I'm going to create a new folder. I'm going to call it scenes. Click OK. I'm going to create another folder. I'm going to call this core. Inside the scenes folder, we're going to create our first main scene. I think this is a typical starting setup for every Godot project. You want to create your first scene. So first scene, I always just call main. I'm just going to make it a sort of a regular node here. It's not going to be 2D seeding or user interface. We're just going to click a regular node. Root names is going to be the same as the name. I'm gonna make this a capital, call this capital main. Click OK, we'll get our first scene here. I'm gonna switch this over to 2D because I don't really need the 3D part. We're not really making a 3D game. Up here, you can sort of like click to open different sections of the editor. Like if I was editing a GD script, I could use the script part. If I was doing 3D stuff for this main scene, I could do the 3D section, but I'm just gonna be focusing on the 2D section for now. All right, so we got our main scene. Now, how are we going to attach a C# script to this scene? I'm just going to click on this main node here, on the main node. On the right-hand side, in the little inspector, the node inspector, down at the very bottom, you'll see a section called script. Click new script. I'm going to pop up this screen. I want the script to be, I'm going to select the language to C#. Make sure you always select the language to C#. Everything else should just be the same. It's going to auto-generate the path and the name. All that should be good. We're going to click create. Boom. So it did open it up in the script editor, but I don't really need that. So I'm not going to be using this editor to edit my C# scripts. I'm going to click this back into 2D part. I'm going to open up my editor now. Before I open up my editor, I actually want to run the project just once. So I'm going to click play. It's going to ask me for the main scene. I'm going to do select current because this is going to be the main starting scene. I'm just going to build the project and run it once. All right, so this should sort of pop up here like this. I'm going to stop that now. So I'm just going to head over into the folder where the project's saved. This is what the folder looks like sort of in the file system. I'm just going to open up my NeoVim right here. I'm going to go to the first main scene. My LSP isn't set up 100%. I'm just getting I get that weird error all the time. I'm running 2 LSPs and one of them's not working, but everything should be good for me to continue this project. So now that I'm actually in the main scene here in the code, we're going to override one of the methods that comes in with every node called the ready method. And just to make sure everything's working properly, I'm just going to run a print statement. This is a Godot print statement. I'm just going to run hello from main node. Head back over into the editor. We'll run that just to make sure everything's working properly. And when I start this up, it says hello from the main node. And now we have the initial project set up with our first script here. We should be able to start getting into the real coding now. So first, I want to prevent the editor from launching in that embedded window. So you can go click on the editor menu at the top. You can go into the editor settings. You can type in embedded, and on the interface part in the editor section, it'll say use embedded menu. I'm just going to turn that off for now. So basically when I run the application, it's just going to launch in the window just itself like this. And of course we see hello from main node. Everything's still working properly. So we're going to do the second most important thing we could probably do here is save this to a Git repository. So I'm going to go ahead and create a Git repository in this folder right now. So I'm just going to exit NeoVim real quick. I'm going to type git init just like this. I'm going to go back into my NeoVim editor. I'm going to save this into Git. Let's go to the main file again. Just load up the LSP, open my Git. I'm going to check, make sure everything's good. All the initial stuff. Yeah, that's all the initial stuff I want to save in Git. Initial project. Oops, got to set something up first. All right, so I'll just commit this, call it initial project. And now we have our initial setup ready to go. Everything's saved in Git. And we should to continue with our first part of this, which is the splash screen. All right, so we're going to add the splash screen. We're going to do a little user interface stuff here. So I'm going to click on my main node. I'm going to right click. I'm going to add a child node. I actually just want to add the base control node. I'm going to rename this. I'm going to call this main menu. This is going to be sort of the main menu node. I'm going to click over here on this little plus thingy, and I'm going to click and set it to a full rectangle. That's going to set it to the full screen viewport, so what the user sees. I'm going to add another child node. I'm going to type in margin container. I want to add a margin container here. Actually, I'm going to add another child node called center container. The margin container, I'm going to move that into the center container, just kind of like that. So the center container, I actually got it set to the full rectangle. The margin container, I'm going to right click the margin container. We're going to add some buttons. We're going to gonna look for button in here. I'm gonna just go click button. That's the first button. This is gonna be new game. And I'll just copy this, paste that right in here. I'm gonna change the text of this button to the exit button. This is gonna be the exit button. Yeah, you'll notice all the buttons are sort of squished together here in a very bad way, because I forgot to add the VBox container, which is gonna sort of lay everything out vertically in a stack. So if I move it like that, boom, you see we got two buttons in the middle of the screen here. If I just start this up real quick, you'll see we got two buttons, can click them, but they do not do anything at the moment. So we'll just stop that. The thing I love about Godot is it's so easy to sort of create and prototype user interfaces and stuff like that. Just love that. So just save that. I'm gonna go save everything in Git again. I'm gonna call this add main menu UI. And now let's add the functionality in the code to make those buttons actually do stuff. Time to make the buttons go click. So the first thing I want to do is I'm in the script for the main scene node that we created in the editor. I'm going to add a property to this. It's going to be of the button class. We're going to call this the exit button. We'll make another one since we're going to be having the new game button as well. Call it new game button. I'm going to actually want to attach two things to this. It's going to be like an export annotation. We're going to be adding export annotations to this, and you're going to see how that looks now. So because I added these export things, if I rebuild the project and I click on the main menu node in the inspector, it'll have two slots for my new buttons. So I'll just rename this button new game button. This is just renaming it in the editor. It has no effect on the code. Exit button. So now I just I click the main scene node where I can see sort of over here where I'm going to assign the buttons, and I can just pull the buttons into their designated slots, and that sets them up there. Now, if I don't do that, the buttons will be null. And if you notice in the code, there's no way for me to tell if something is going to be null or not. And like the editor is not going to warn me of that. So we're going to fix that. If I go into the CS project file, it's going to be the name of your project, and the ending is going to have CS proj. If I go into that file, I go down to the property groups. I'm going to add another property group called nullable. If I save that, go back to my project, save this, I'm going to have to quit the editor. I'm going to go back into my editor, go over here to the main file again, save it, and you'll notice now I'm getting diagnostic warning errors. So if I just head over to one of those and I look at that, non-nullable property exit button. So what I want to do is I'm going to be adding a question mark on the end of these buttons, because these buttons could be null in the code. So these are sort of nullable buttons, but because I set them in the editor, they won't be null. And you're going to see how we're going to have to deal with that a little bit later. Let's make the buttons go click now. So inside the ready method, so the ready method is called when the node, so both the node and its children have entered the scene tree, and all of the children have their node's ready's callback triggered, then this ready callback is triggered. So here we're going to be setting up the click button functionality. So what we're going to be doing is calling this.exit button.pressed. We're going to be using the pressed event. I'm going to be just attaching sort of a anonymous function handler, and it's going to kind of look, the syntax is going to look like this. Kind of got this arrow functionality going on. See, now it's telling me, oh, this could be null. So in this exception, here's what I'm going to do. I'm going to be throwing an argument null exception. I'm going to be calling argument null exception, throw if null, and basically I'm going to check if the exit button is null or not. So I want the application to throw an exception if this button is null. That's going to tell me that I did not set this up in the editor, and then it would sort of remind me to set it up in the editor. So now when that button is actually pressed, what are we going to do? We're going to be calling getTree.quit, and this is the main scene. So this should exit the application. I'm just going to get rid of that go.print statement, so we don't need that anymore for now. So now if I launch it, the button shouldn't be null. If I click exit, you'll see the window closes and the exit button is working properly. And now we just need to get the new game button button sort of working. And essentially what happens is when we click the new button, we're going to create like a game scene and then attach it to this main scene node. And we're going to be getting into that. So let's focus on the next part, which is going to be creating the game scene, the scene that we're actually going to be playing the game in. And then the new button will load that scene when we click it. So I'm just going to head down into the scenes folder here, and I'm going to create a new folder inside of that one. We're going to call this the game scene, for lack of a better name. This folder is going to hold the scene for like that's going to be playing the main part of the game here. I'm going to create another scene inside that new folder. I'm going to give it a 2D scene node for now. I might have to change that up. And again, I'll be calling this game scene. Everything should be filled out properly here. I'll press OK. It's going to open up this new section here. So I've got the tab for the main scene and I got the tab for my new game scene here. First thing we're going to want to do is attach a script. We're going to click new script over in the right hand corner here, the bottom right hand corner of the inspector. That should be all set up. C#, the game name, the name should be good. I'll click create. Again, I don't need this as the script editor, so I'm just going to close kind of these off here. I'm not using this to edit my scripts at all. I'm going to add behind this, we're going to add a color rec just to change the color of the background. So we'll set that. Oh yeah, that's not going to work. So I actually want to change this type of node back to just a regular base node. And then when I set it, it's going to show the full color rect here. We're going to change the color of that. We're just going to darken that up a little bit. That's kind of going to be the background for the game scene. Now, since I changed the node type here in the editor, I am going to have to go into the code here because it automatically generated this as a node 2D. So I'm just going to change this back to node. That should be no problem there. All right, so back inside the game scene, we got the color rect for the background. Now that I have the simplest version of a scene set up here, I'm just going to try to load this now into our main scene class when we click the new game button, which isn't too difficult to do. All right, so let's jump back into the code here. We're going to go ahead to the main file. We're going to be setting up another button handler, just like the exit button. I'm going to switch this to new game button. I'll add another throw if null exception for the new game button, just to remind me in case I forget to set that in the editor. Let's change what the button press actually does here. We'll just change this up. So what we're actually going to be doing is we can create a variable for our game scene. I'll call this var game scene. It's going to equal resource loader. This is what we use to load resources, as you could tell by the name, inside Godot. And we're going to be loading a packed scene. We're going to have to give it the path of the scene. So what I can do is I can jump into the editor. I can go to the game scene class in the bottom left hand corner. I can left click. We want the scene class, not the script, not the CS script. I'm going to right click on that. I'm going to click copy path. We'll go back into the editor here. We're going to give it the path that we just copied. Then we're going to call instantiate, the instantiate method. And we also are going to give it the class of the scene itself. So we called that the game scene, as we declared over in this class here. So now we have a variable with a loaded and instantiated game scene. So what we're going to do is we're going to call add child. And what this does is this is going to add the game scene node to this main node. This is the script for the main class, and it's going to add the game scene to the main class. And let's just start that off and see sort of what happens and what that looks like. I'll just start up the editor here. So if I click the new game button, all right, we see that the screen turns black, and that's to be expected as the game scene itself, as you can see in the editor, was black, and now it's just being loaded into the main scene. If you click the remote button, it's going to show you like the scene that's running in the game at the time, and you can sort of inspect the scene itself and sort of do something with it. So, you know, here's the window for the game, and if I turn the color rect off, you can see it turns the color rectangle off. You can turn it back on. You can see the menus behind here still. We can hide the menu too. We'll probably add some code to do that in. But right now, as we can see, the new game scene is being loaded when we click click the new game button. And now we're just gonna have to sort of expand out from here in the code. But first, we're gonna head over and create the new player scene. I'm just gonna head down into the scenes folder. I'm gonna create a new folder called player. Type that in. Go down here, right click again, create new scene. We're gonna call this the player node. I'm gonna select a node 2D. That's perfect. Everything should be good to press OK. Okay, so we're actually gonna be changing the type of this, and for this we're gonna be selecting the area 2D node. And this is gonna be used to sort of define like an area 2D with a collision area, and then we're gonna attach sort of an image sprite to that. So we'll just add, or we'll just change that node to that. We're gonna also, you'll notice it says there's a configuration warning. There's a little warning symbol right here. We're just gonna click add child node. That's because it's looking for a collision shape. So we're gonna give it the collision shape. For the collision shape, I'm not gonna put anything just yet. We're gonna leave that warning on. I'm gonna add another node to the player node. This is going to be the sprite 2D node. This is what I'm going to be using to display the image of the player itself. And so we're going to need a texture for this image. So I'm going to create a new folder. I'm going to right click on the resource, the top level resource folder. I'm going to create new folder. I'm going to call this assets. This is where I'm going to be putting all the images for the project. Click OK. We got a new folder there. Now I'm just going to add an image into this folder. All right. So I've added an image asset inside of my assets folder. I'm just going to be using this picture here. It's a little SVG picture. So now to attach that to our little player node, I'm going to click on the sprite 2D here. You'll notice on the right hand side, it has like the texture box right there. I'm just going to drag the image over into the texture box. And it's going to be placing it like that. And now it's way too big for our liking. So we're going to just adjust this down in size a bit. So if I click on the sprite again and I go down to the node 2D transform section here, I can actually set the scale. And I think I want this to be around 32 pixels in size. So I'm just going to try a scale of 0.1. Let's just see how big that is. There's a little ruler widget here. You can click R for ruler mode, and I can actually drag to see how big this actually is. So this is 108 pixels. You know, that's not bad. Maybe we'll just keep it 108 pixels for now. So now I'm gonna change the collision shape to match this image right here. So I'm gonna click on collision shape. I'm gonna click new shape. This looks like it's going to be a rectangle shape. So I'll just click the rectangle shape. And you notice there's gonna be like these little sort of orange dots that these orange dots appear on the user interface. These let me sort of click and drag to see what the collision shape is going to be. I'm going to have to go back to select mode here. I'll move the collision box to centered here. I'll adjust it just to make it a little bit bigger. Adjust that like that. Oops, put the wrong node. So I'm going to lock this node in place actually. So I can click the sprite 2D. I'm going to lock that. You'll notice there's a little lock widget on the editor right here. Then I'm going to take the collision shape again. I'm just going to readjust this just to make this big enough. I think I need to make this like that. There we go. Now we got like a collision shape that's for the most part covering this. You know what? Maybe this should be a different shape, because this isn't much of a rectangle as much as it is more like a circle. Let's try the circle. Yeah, we're gonna use the circle shape. I don't even know why I chose that other one to begin with. Let's just center this sort of here. And so this is gonna be the collision shape. I'll just lock this in place. So we have an area 2D node. It has the collision shape node as one of its children. It also has the sprite 2D node as one of its children. This sort of lets us show the sprite 2D, lets just show the image. The collision shape we're going to be using for collisions in physics later on in the game. And now we can add this directly to our game scene. So there would be more than one way to do this. I could load it into the game scene like programmatically in the code, but I'm just going to, for now, I'm just going to attach this player node directly into the game scene itself, sort of like this. And I'll just kind of maybe put it here in the center for now. Let's just start this up and just see if everything's working as expected. Start this up, click new game, and boom, we have our player sort of just chilling in the middle of the screen there. Now we're going to add the functionality to move the player around. There's going to be sort of two parts of this. I'm going to be adding an ECS system into the game. Now, a game of this scope, kind of unnecessary, but I love to build all my games with an ECS system. So I'm going to be doing it for demonstration purposes. I'm going to squeeze it in here, and we're just going to work on we're going to add in the ECS system, and then we're going to get the player node to move around. All right, and to add an ECS system into our game, we're going to be adding Arch, which is a high performance bare minimum C# ECS system. Now, I've been using this for a small amount of time now, but I'm actually enjoying my usage of it. So we're just going to head down here, and it says .NET add project. We're going to copy this. This is how we can add this into our project. I'm just going to go to the command line sort of my project folder here. I'm going to paste that in. Oops, I got to get rid of the project part of this. So I'll just get rid of this in the command, and boom, .NET add package. If we go back into our CS project file, you'll notice that we have a new package reference, Arch, and that's going to be our ECS system. So what we're going to be doing is I'm going to be going into the core folder. I'm going to be adding a new class. I'm just going to call this Dodge Game class. This is just going to be the Dodge Game.cs class. Let's just fill this class out a little bit. Now, this class is going to be responsible for sort of running the game itself. So this is going to sort of have the ECS system, and for the most part, the user interface is going to be calling functionality from this class to drive the game. Now, we can just make sure that we have our ECS system here. I should be able to do a using Arch. It's not detecting it. I think I might have to restart my NeoVim. I'm going to restart my NeoVim. I'm going to go back. What was that class again? That was the Dodge Game.cs class. We'll see if that loads up properly. Yeah, okay, everything's good. Arch is in. We're locked in. We're ready to go. So now we're just going to sort of set up our initial game class here. It's going to set up the ECS system when we click new game, and we'll do a little functionality to get the player moving around the screen. Okay, so to add the ECS system, we're going to be adding a property to this class, and this is going to be of the world type. And I'm just going to have to import that one with this, get rid of this import up here. So this is going to be the world class. The world class is the ECS system. It's what stores and registers all the entity and all of their data is attached to it. We'll just call this ECS, I guess, or ECS like that. Now this is going to be created right here when this is made just like this. So I'm going to add this right here. So now we have the ECS property. Now we've got to define some data to attach to that property. So one of the first pieces of data that I want to attach is going to be a position, the position of the entity basically on the screen in the world, so to speak. And we'll just start with that for now. Let's create a new method down here. Got my snippet. We'll call this new game. This is going to be the new game method. When we call new game, what we're going to do is we're going to clear our world, which is basically just going to reset our world to have no entities or data. After we clear the world, we'll create the player entity. So we're going to call this .ecs. I'm going to attach this up here. I like to add this when I'm calling members of the class itself. It just makes it more clear in the code where this thing is coming from. We're going to call this.ecs.create. That's how we create new entities. And when we create it, we actually create it with the data we're going to be creating it with. So we're just going to give it a position. The position will just start, I guess, at 0, 0 for now. We'll be switching that up a little bit later, probably. I'm going to actually save this into a variable. So I'll call this variable layer. And I actually want to return the player entity itself. itself. So I'm going to return player just like this after we create it. Okay, so now we got like a new game method, which is going to reset our ECS. And for now, it's just going to be adding the player to it. Let's head over to our game scene. So the game scene is actually going to take a reference to this game class itself. So we'll just call this the game property. We'll call new right here. So this will always be created right when this object is made, right when the scene is made. I'm going to create a method inside this class as well, the game scene node, which is let's just go to it. So this is the game scene, and we're working on the script responsible for this scene itself, not the player node, not the main scene. We're in the game scene here. So we're going to call this new game. What this is going to do is it's going to call the new game method from our game class property. This is going to return our player. So I'm going to save this into a variable. And the reason why I wanted to save this to a variable is because the player node itself is going to have a reference to the player entity in the ECS. So we're going to be setting that up right now. If I head over into the player node, oops, we did not make a script for that yet. So let's go, we'll click player node over here in the left. We'll go over the bottom right where it says script, add new script, player node, everything should be good. Language is good, create, don't need this. I'll close this down. So we got a script for the player node. Let's head over to that. Here we're going to have a property and it's going to be the entity. We're going to have to import arch.core like so. And this is going to be the player entity. So I'm going to just call this player. This could be nullable. So I'm going to set this to nullable. And now we're going to be seeing sort of how we're going to be moving the player around. Now I'm going to be overriding a method called process. And this method sort of runs every frame. So every frame we're going to be doing stuff with this player node. And what this player node is going to do is it's going to check if we have this dot player not equal to null. We're going to set our position of our node. So the position is a property of this area node itself. And this is going to determine our position on the screen. So we're going to be setting our position every time with this dot player. We're going to call dot value dot get. We have to call value because this is like a nullable. It's sort of like a nullable object. We have to sort of get the object out of it. We're going to be calling get, and then I'm going to be getting the position. I sort of write it like this. I'll have to import Arch core extensions. Oop, and I actually did this a little bit wrong. Let's move this into a separate variable because these positions are actually different. So this is a position I'm using sort of in my ECS system over here. And this is a vector2 position. So I'm going to be calling new like this, and we'll be setting position X to position Y, sort of like so. So the position of this node is going to be based off the position of the player entity in the ECS system. And we're going to see how this pans out. So that's the script for the player node itself. So that's this player node that we created. Now we're just going to adjust the game scene here. I'm going to go over to the game scene script. When we call new game, what we're going to be doing is we're going to be setting, before that, I'm going to have to add a property, and this is going to hold the player node class. We'll call this player, I guess. And I'm going to have to add the export annotation, and I'm going to have to set this in the editor because of the way I sort of set up the scene. So I'll rebuild the project here. The export thing should say player, the name of our variable. I'm going to drag the player node over, click it in like that. Now we have access to it in the code. I'm going to have to set this to show that this could be nullable. So now when we click the new game button, we're going to be setting this dot player dot entity. Oops, did I do that wrong? Oh yeah, I called it player. Okay, that might get a bit confusing. Might have to change the names later. But we're going to be setting that to the player entity here. Ooh, that is getting a bit confusing. So I'm going to rename this to player node 2D. We'll rename this to player entity, and that's a little more clear. I'm going to call a argument null exception here and throw if null, because the player 2D node should never be null like at at this state. So I didn't set something right in the editor at this point. We're gonna set it like that, format it. So we call a new game, we set the player entity to our player entity node. Now we have to go to the main scene class where we sort of click the new game button, and we're just gonna adjust that a little bit here. There's a few ways to do this, but I'm just gonna sort of, actually no, I'm gonna go back to the game scene. We're gonna override another method called ready. So this method triggers when the game scene's been added to the main scene node and sort of everything's okay and ready. Then I'm gonna call this.newGame, sort of like so. So when the game scene gets added to the game, it's just gonna sort of create the new game automatically. Now, since we're not updating anything yet in this game, we're not updating anything in the ECS system, nothing should sort of change, except for maybe the location of our thing on screen. Ooh, see, now my debugger's helping me out here. Oh, yeah, so I set the player node was null. I didn't, because I changed the name of that, I think. And do I have to set anything different here? Okay, let's just restart that, see what happens. New game. Okay, so yeah, we see this gets moved up into the corner of the screen because now it's sort of following where the player is in the ECS system. Okay, so first I actually want to add the movement handlers into the game. So to add in sort of like key bindings and input maps and stuff, you gotta go over to the project settings. There's a tab called input map, and this is where we're gonna be sort of adding like actions that we attach to key binds. And you're gonna see how this sort of goes. So I'm gonna call a bunch of these move. This one's gonna be called move up. I'm gonna add this. I click over here, and then I can select the key that I want to use to move up, and I'm going to click the W key to move up. It's going to show the W up here. I'm going to press OK. We're going to add a new action. We're going to call this move down, enter, move left, enter, move right, enter. So then I'll click this down. I'm going to press S, you can select S there. OK. Move left, click this plus button. Left is going to be the A key. Click OK. Click over here. We're going to select the D key to move right, press OK. So now you can see we have an action called move up, and it's the W key, an action called move down, and it's the S key. So WASD movement attached to sort of a name. So now we have like an input mapping that's been set up in the Godot editor itself, and I'll show you how we access that in the code. All right, we're going to head over into our code here. The game scene is the appropriate class to do this in, so I'm going to show you how to set this up. So we could do this in either the player node itself, or we could do it in the game scene class. I'm going to do it in the player node itself. So I'm going to do it in the script for the player node itself. So what we're going to do is we're going to be defining a bunch of string name properties first, and you're going to see how that goes. So we're going to do public static. This is going to be a string name. This is a special object called string name. It's a special Godot object, and it's really important to declare this statically up here as a member. And I'm going to tell you why in a second. So we'll call this move left, and it's going to equal new, and then we enter the string that we used for the input mapping. So I believe it was just move underscore left, and we're going to do this for all the directions that we've defined. So we'll call this move right. This one will be move down. This is move up. We'll have to change this here. Right, down, up. Okay, so I've declared a bunch of string names that match the names of the input mappings that we set in the editor. Now we're going to be, since we're overriding the process method, and this method is called every frame very quickly. So the reason why we declared these statically up top, because we're going to be using these in the process method. So if I had to create new ones every frame, that would be quite the performance hit, but we're not going to be doing that. So we're in the process method sort of down here. here. We'll do this only if we have sort of the player entity. So we'll do this in this if statement, but I'm going to be calling if input, which is sort of a singleton. It's like a Godot singleton. We're going to be calling is action pressed. And then we're going to be giving it the members that we defined up top. So if is action pressed move left, what are we going to do? We're going to be changing this position variable. So let's actually move this if statement above here, because this is going to eventually affect the end position. So if we click move left, we'll do position.y less equals 1, just for now, something like that. It's kind of a magic number. And we're going to do this for all the directions again. So I'll just change this, move right. So moving left, we're actually going to be changing the x-axis and the x-axis, and we'll set this to minus, not plus. Move right, also the x-axis, but we'll keep that at plus. Let's change this, move down, and that's going to be, I think, plus on the y-axis. So I think we actually keep that like that. We're going to change this to move up. And I think we have to subtract on the y-axis. Okay, let's see what happens. Let's just test this out. Okay, I started it and it's running, but something's not right. Okay, so I actually did this wrong, and we're going to show like sort of a little idiosyncrasy with this. So the way this was working was wrong. What I need to do is, this is a structure, so I need to sort of call this like this. I'm going to call reference is going to equal reference, because we weren't actually changing the entity in the ECS system itself. We were getting a copy of the position. We were changing the copy, but we weren't changing the original. So the position is a struct, and structs in C# are sort of copied, and you're not sort of working on the exact reference itself. So I got to change this to ref var position, ref this to get the position and to actually manipulate the position itself. And then if I start this up, and you can see now when I move, we are moving. I'm pressing the D key, A key, S key, W key, and we're moving around. We're rolling. Okay, so now we have our player and our movement sort of set up. So now we're going to create the enemy scene. So I'm going to just right click on my scenes folder, create a new folder. I'm going to call it enemy. Hope I spelled that right. We're going to right click on that folder. I'm going to create new scene. We're going to call this the enemy node scene. It's going to be a 2D scene. It's going to be just like the player node. Click OK. It should pop up like that. Just like the player, we're going to be changing this to the area 2D node. We'll click that. We're going to be adding a collision. If I can spell that right, collision. And we're also going to be adding a sprite, so we can sort of add an image to this node just like before. So for the texture, we're going to be doing something a little bit different. I'm going to select new canvas texture. Oh, actually, no, I want to do this different. So I'm not going to use a texture. I'm not going to use the sprite 2D for now. I'm just going to get rid of that. I'm just going to actually add to the child node a color rect. Oops, selected right there. It's going to zoom in here and change the position. I'm going to change the color. I can click the color rects thing on the right hand side here. I'm going to just adjust the color. Maybe we'll do something like oh no, my background's a bit dark, so I'm going to make this a little bit lighter, just like that. And then we'll add the collision shape. This is going to be a rectangle. Move that over here like this. I got to line that up a little bit better. Okay, color rect's not exactly centered. Center this. So for the enemy node, we're just going to be using sort of a blue square for now. Nothing very fancy. And we're essentially going to be spawning these onto the screen, moving them towards the player. And if they hit the player, it's going to destroy the player. Okay, and to start spawning our enemies onto the screen, first we're going to define like an invisible path along the screen. So we're going to create, we're going to search for a path 2D node. We'll select that. We're going to click on that. I'm going to click up here in the control widget. I'm going to select add point right here. And I'm going to start defining some points along the window edge here. And it's important to do this in a clockwise position. It's important to do this in a clockwise direction, as we're gonna sort of need to spawn the enemies and turn them in a specific direction that's going to sort of be based on this. And we can click close curve. So I'll set the 4 points there. I'll click close curve, and then we can sort of see, if I sort of select off the node, we can see like there's a little path along the edge of the screen. Now I'm going to add a child node to the path 2D node, and this is going to be called path follow 2D. And we're going to be using this to select a random place along this path to spawn our enemies. The second thing I want to add to the game scene, I'm going to add another child node called a timer. You can implement the timer in the code, but they've already implemented sort of a node for this, so we can just use that. And we're going to set the timer to 1 second. We'll set it to auto start, and we'll just keep the process callback to idle. So we'll be checking this sort of, this will be updating sort of every frame in the process method. So we're just going to leave it like that. And we're going to head back into the code here. Let's move over to the game scene script. We're going to be exporting another property. We're going to be calling this, we're going to set this type to the timer type. We'll call this timer. In our ready method, we'll set the callback for the timer. So we'll say this.timer. We'll call this.timer.timeout event. And then we're going to add our callback method here. Add the arrow functionality. I'm going to set another argument, null, throw if null exception, because the timer should always be set in the editor. And on timeout, just for now, we'll just do a GD print statement, and I'll just print out hello from timer. Now let's go back into the editor. We're going to rebuild the project. We're going to set the timer node in the export section here. Pull that over there. Let's start this up just to see if the timer is working. I'll click new game. Now every second it should be ticking hello from timer. Now 1 second might be too fast, but we're just going to keep it like that for now. So now essentially every time the timer sort of times out, we're going to spawn an enemy onto the screen. We're going to pick a path with our path node, and then we'll set up the ECS system to sort of run the enemy's movement. So I want to create another export variable, and this is going to be for the path follow 2D that we had before. We're going to call this mob spawn location. I'm going to go into the editor and set that real quick. Rebuild the project, click the game scene, drag over the path 2D, set it right there. Okay, so when the timer goes off, first thing I want to do is I'm going to call this mob spawn location. We're going to set the position. Oh no, we actually want to set the what's called the progress ratio property, which is going to define like the distance along the path. And we're just going to be calling one of Godot's random f methods here. And this is going to be a random floating point between 0 and 1, which is going to set our progress ratio, which is also supposed to be a number between 0 and 1. Let's add another throw if null for the mob spawn location, because that should always be set in the editor. Now let's load up the enemy like we did before. I'm going to search for the resource loader that I used before. I'm just going to copy this code, come back here, paste that down there. I'm going to rename this to enemy node. We'll change the type in the instantiate to, what did I call this? I think I did call it enemy node. Yeah, it's an enemy node. Not sure why that's not popping up. Oh, that's right. We did not create a script yet for our enemy node. So I'm going to go into the enemy node in the editor, select it right here, go over to the script section again, click new script, enemy node, that's good, language is good, click create, just close all these since I don't need these. All right, so we should have an enemy node here now. Enemy node, there it is. So I'm going to instantiate the enemy node. We'll set the enemy node's position to our mob spawn location's position. Oops, just format that. And then we'll add the child node to the scene. And let's just see how this works out for now. We'll go over, I'll start the project again. I'll click new game, and my debugger's going off because I didn't set something here. Oh, that's right, I forgot to set the resource location, the string here that I have highlighted, so it can go back to my editor. I'll go select enemy node, we'll copy the path, I'll paste that right into there, and that would explain why my timer wasn't working. We'll click new game, start that back back up and we can see we are now getting things randomly generated. However, the path did not follow the screen size change, which is okay. At least we kind of have it working for now. If the screen was still this small, it'd sort of be going along the path just like that. You can see new squares being added in. Okay. All right. So now we have sort of enemies being spawned into the game, but they don't do anything yet. So we're going to add the functionality for them to actually move around and sort of attack the player. So we're going to head into the code and we're going to go to our game class. I want to set up the ECS to handle moving the enemies. So we're going to create our first system. I'm going to create a method. I'll make it static. We'll call it enemy. We'll call it movement system. And essentially the parameter it's going to take is a double representing the amount of seconds that has passed between frames. And this is something we're going to get from, and this is something we're going to be getting from the process method with the nodes itself. We'll see that later. First thing we're going to do is we're going to declare a query for our ECS system. So this is going to be a new query description. We're going to call with all, and I want all the entities with a position, and we're going to actually need another type of data. We're going to call it velocity. This is going to represent the direction and speed the entity moves across the screen. The enemy moves across the screen. And velocity is going to be like a vector on a Cartesian plane. So it's going to take two data points. We'll call this float X and float Y. So we're going to add that into our with all as part of the query here. So I'm going to add velocity. Now we're going to call this .ECS. Oops, I don't want to make this static because I want to use the ECS system. Forgot about that. I'm going to call this .ECS.query, and I just sort of write it like this. The first parameter is going to be in with the query we wrote up top here, and then it's going to take a lambda which sort of loops through all the entities. I'm going to have to write it sort of like this. Here it's going to take an entity E as the first parameter, and then it'll be a reference to the position. I'll call this pos, and a reference to the velocity. And if we fill this out, essentially we're going to be looping through each entity, and we're going to be setting its position, and we're going to be incrementing its position by the velocity. So I'll just plus equals velocity X here. We'll do that for Y as well. And now, so all of the enemies in the game will have a position and a velocity, which is the direction they're traveling and the speed. And this system is just going to query the ECS system and just move them every time I call this method. And I'm going to create another method now, and this method is going to be used to add new enemies to the game essentially. And the parameters that it'll take, it's going to take a position and a velocity, and we're actually going to return the entity that is created. Should be pretty easy to fill out. It's just going to be sort of like we did 15 lines up there, but we're going to be giving it a little bit different inside here. The position, velocity, and we'll return this variable. I'm going to rename this the enemy. Now let's head to the game scene script. So the script that's sort of running this game scene here. And inside that timer, we're going to be changing things up a little bit. All right, so first we're going to get the velocity. We're going to calculate the velocity, which is essentially the direction and the speed that the enemy is going to be moving. So to get the direction, I'll make a new variable called dir. We're going to get the mob spawn location. We're going to call the rotation property, and the rotation is going to be in radians, not degrees. So this is a float representing the radians. So we're actually going to multiply this by, we're actually going to add 90 degrees onto this. And since we're talking radians, we're going to have to do pi. I'm going to have to find pi. I don't know if I have pi. Oh, I do have pi. And I'll do pi divided by 2. So the direction should be sort of the rotation that we get from the mob spawn location. That's sort of this path 2D thing here that we're using to sort of get the location along the path. We're going to get its initial rotation. We're going to turn it 90 degrees counterclockwise, I believe. We'll figure that out. We'll figure that out as we go. Now I'm actually going to have to convert this into the velocity. So I will make a new variable called velocity, and we're going to have a new velocity velocity here, and the x is going to be math f times cosine, I believe this is. And does this take radians? If this is taking angles, I don't know if this takes radians. Wait, maybe there's a GD dot cosine. There's a go dot math. Okay, I had the wrong thing. So math f cosine is in radians, so we're good. So so the direction of the x velocity, the x value of the velocity is going to be math cosine, and the y value should be math f sine of the direction. We'll have to check all these. We'll be testing all this out later. So we got the velocity, the position. We should already have the position. So what we're going to be doing is calling this dot game, I believe it was, our game property. We're going to call add enemy. We'll give it a new, we're going to start with the position here. We have the velocity up top. I just sort of have to convert the Godot position to my position for my ECS. So I'm just going to sort of do this manually. All right, so we're calling our add enemy method we made earlier. That's going to add the enemy in. This is going to return the entity, which we're going to have to set in our enemy node that we're adding to the screen. And I don't think I actually put that on the enemy node. No, I did not. So let's add that in. It's just going to be sort of like the player node. There's probably some refactoring you could do to make a base class out of this, but I'm not going to be doing that for now. I'm just going to sort of do this a little quicker than normal. We're going to have to import Arch for that. We'll call this entity field. It's going to be the same thing as this. I'm going to copy this, paste this over here. I actually don't need the movement handler stuff here. We'll get rid of that. I'll change this to entity because I did a name change. Oh, that's right. I got to import one more thing from Arch as well. All right. So what we have here is the enemy node has a reference to its entity, and it will move itself based off of its entity's position now. I can go back into the game scene. We can set this up properly. We'll set the entity to the entity that's returned. And I think I have it all set up here. We calculate the velocity. We already know the position. We have the position and the velocity. We add that to the ECS system. We set that to the enemy node. There's only one way to find out. We'll just boot this project, click that, and see what happens. Okay. Oh yeah, that's right. I actually did not set that correctly. So we're actually not calling the ECS systems update. I forgot to add that in. So if I go over here, we're not actually calling the movement system yet. So we're going to add that in. We can do that right from our game scene itself. We're going to override another method here called process. And this is where we're going to be getting the delta for the time between frames. So we're going to be calling this .game.movement system, and I'll give it the delta. And let's see what happens now. And the enemies are in fact spawning, and it looks like they're moving in the right direction here. Looks like they are in fact moving in the right direction. The ECS is picking them up and moving. It's actually kind of cool. It's fairly smooth. Now, nothing happens when we collide with these objects yet, so we're gonna have to sort of add the functionality for the collisions now. So we'll do that. I'll turn this off. We'll head back to the code. So to set up the collision handler, let's go over to the player node, and that is you'll notice it's an area 2D. If I go to the player node in the editor, select it, and I go to the node tab over here next to the inspector, I can see like all the different signals that are being outputted that I can sort of connect to in the code. And I think the collision shape.2D, so the signal that we're going to be attaching to is probably going to be area entered, maybe bodied entered, but we're going to do area entered because I think that just represents sort of the collision area right there. And I'm going to be squeezing in an observer pattern here when it might not be 100% necessary. The reason I want to do this is I want to do this as an example. So I'm going to create another property here, and this is going to be of the action class. And you can think of an action as like sort of an anonymous function that you can pass around. And we'll call this on hit. Do I have a ready function here? No. So we'll set this up in the ready function. We'll override ready, and we'll essentially call this dot area entered event. We're gonna plus equals. We're gonna add a little lambda functionality here. And we're gonna be calling, oh, this actually takes parameter. What is this? An area? So this must represent like the area 2D that's been entered. So when the area is entered, we're going to be calling this dot on hit dot invoke. And essentially this is just going to call the action itself. And we're going to get a little warning here because this could be null. Now you can kind of add like a little if statement here by just using this question mark. What this will do is essentially it'll check if this is null or not before it invokes this statement. So if this was null, it just wouldn't do anything. So let's head back to the game scene script. We'll head to the ready method. I should probably refactor this out. This is getting a little bit verbose. I'll just refactor this out real quick into a method. We'll rename this method to init timer because this is just setting up the timer. I'll have to add the non-null things in the appropriate method here, and then we'll use the rest of this method to set up our player node on hit lambda. So we'll just set up the syntax for that here. We're gonna call an argument throw if null for the player node itself because this should always be set, I believe. Yeah, we're exporting that in the editor. And just to test out the functionality, we're just gonna do a print statement and we'll just write hit just to see if it works or not. Not sure if I connected everything correctly. All new game. Oh yeah, looks like we're getting hits. So you can see sort of, it's really hard to see. I can't change the size of the editor, but you can see the hits down here where my mouse is circling. If I get hit, 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 hit. So we are detecting hits. We are detecting the hits. Now we can just decide what we want to do when we get hit. All right, so we're gonna set up what happens when we get hit. So what I'm gonna do is I'm gonna add a little like player HUD here you can think of. Let's add a control node to the game scene. The control nodes are used for graphical user interfaces, so the GUIs. And we're going to set this to the full screen. The control will always be the full screen. I'm going to add a label. I think we can do a text label. We're going to add that to this. We're just going to hard code what it says, and it's going to say you are dead. We're going to make this fit content on, auto wrap off. I want to center this in the middle of the screen. And I want to make the font a lot bigger. So I'm just going to do a theme override directly. Normally I would sort of not do it like this. I would use Godot's sort of theming mechanics, but we're just going to change this for now. See if I could go to theme overrides, font sizes. I think it's just normal I can do. And then I can set like 25. Let's make that bigger. 64. Boom. You are dead. We're going to hide this label. I'm going to go back into the code and I'm going to declare this as a property up here. So we'll call this dead label. I'll change it here to rich text label. We'll set it in the editor. I'll rebuild this. I gotta pull this over to our export property, the dead label. So it's hidden. And what we're gonna do is we're basically gonna show it when the player dies. And it's pretty straightforward. So we're gonna go back to our on hit method. So if the player gets hit, we're gonna call player node.2d.hide. So we're gonna hide the node. And then we're gonna call this dead label.show. And I can just use the quotation mark to check if it's null. And I actually want to add onto this I'm actually going to change this, the node type to a panel container. And you'll see why I'm doing that, because I'm going to set this panel container's theme to be sort of a flat background here. And I'll just change the color of that because it's not very nice. So basically we're going to show it like this. I think I have to center this again. Center that you are dead. And I don't actually want to change this. So I don't want to show and hide the label itself. I want to do the control panel. So I'll hide the control panel initially, save that in the editor. I'm going to go up here where I set the rich text label. I'll change this to panel container because this is a panel container now. I'll just keep it the same name, even though it's not very appropriate. I'll have to sort of set it in the editor. So yeah, I got to get rid of this. this, assign this here. Wait, assign this, yeah, assign that like that. I'll rename this to dead panel in the editor. All right, so the dead panel is set there. Okay, so when the player gets hit, it's gonna hide the player and it's gonna show the dead label. Let's just see what happens. Let's start this up. All right, new game. And I should really start in the middle of the screen, but let's see if I get hit. Oh, you are dead. Okay, so that appears to be working correctly. All right, let's restart that up again. There's a lot to be sort of desired in terms of game functionality, but to start this off, we have ourselves a game. Now the problem here is that when these nodes leave the screen, they're not actually being deleted. So they still exist in the game. This is like, you can kind of think of it like a memory leak in a sense. Like we just have all these extra objects that don't need to exist. So let's just fix that real quick. We're gonna go back into the enemy node section here. So we're in the enemy node here. We're gonna be adding another node to the enemy node, and this is gonna be called a visible on-screen notifier 2D. Now, this is a neat little thing. If I go and look at the signals, we can see screen entered and screen exit. So you can probably see where we're going with this. We're gonna head back into the code over to the enemy node. I'm gonna be exporting another property into the editor, and it's going to be that visible on-screen notifier 2D. We'll call this screen notifier 2D. I should probably rename this, but we're not gonna do that. And then we'll set up the functionality in the ready method. We'll call this screen notifier.2d screen exited. I believe that was the event. We'll attach our anonymous handler here. Oh, just check that node again. We'll do a throw if null as is tradition because we're setting this in the editor and I want to know if I did not set it in the editor or not. Okay, so if we exit the screen, what do we do? We're gonna call this entity.value. So we're gonna need access to the ECS system to destroy this node. So I'll probably just do the callback. I'll add a property here. We'll call this on-screen exit. So we're going to use the observer pattern just like before. So if we exit the screen and we have the entity, we'll call our new on-screen exit callback. And then in the game scene, when we create the player node or the enemy node, we can set up the callback functionality on-screen exit, add the lambda syntax here, and essentially when the enemy node leaves the screen, we'll call remove, we'll call this.game.ecs, we'll get the ECS system. I believe we call destroy. Yep, this destroys the entity, I'm pretty sure, so we'll be calling destroy. And I'll have to move this down here because I'm gonna need a reference to this entity that we created up top. So that will remove it. So that'll remove it from the ECS system, but the enemy node, the 2D node sort of itself, this thing is going to exist sort of in Godot. So we're gonna have to remove that from the child scene too, which isn't too hard to do. We're gonna call enemy node.queueFree. And what queueFree does is that will remove sort of this enemy 2D node from the game scene itself. Now we can start that up, call new game, just to see if anything's breaking. So yeah, I already got exceptions because I forgot to set something in the editor. That was right. So this is why I do the throw if null thing, because I forgot to set. Let's go into the enemy node. I gotta put the export variable on this. So I'll put this up here and we'll write export. We'll export this into the editor. I'll swing this over here, assign that there. All right, we'll start that back up. New game. Okay, so when these things leave the screen, I'll have to dodge this until they leave the screen. They should be being removed from the ECS system and removed from sort of the game scene itself. Something going on here. So essentially when the enemy node is being processed after the entity is being destroyed, it still has a reference to it. So I'm going to have to actually call, we're going to add another thing to this if statement. If this.entity.isAlive.value.isAlive, and this checks if the entity is alive in the world or not. So after destroying it, it shouldn't be alive. That should remove those error messages. All right, let's dodge some creeps. We shouldn't see any issues in the debugger, and it looks like it's working properly. Oh, and now I'm dead. Okay, yeah, so let's check the remote scene here as this thing's playing. So we can see the nodes being sort of added been removed here from the scene. Okay, and now essentially we have ourselves a little game. Now, as far as game development goes, there's a lot to be desired. We did not go through so much. I mean, there's so much more about Godot and game development itself, but this is just sort of a little example of making a little 2D game in Godot. Sort of quick and dirty, not perfect, but it made a cool little game, and now I'm dead. So if you did enjoy the video, please consider liking and subscribing. It really helps out the channel, and I hope you all have a wonderful day.